All right, so this is the calculations for our fusion of ice experiment. Just before we get going too far, make sure that you are using formulas to help drive everything you're doing and try and stay sort of in step with what they're saying. So this is the formula we're using for this one. And we're using this one because, well, this side is the ice, and what happens to the ice is it melts. That's what this will be. And what we're looking for is that molar heat of melting of ice or fusion of ice. And then this is the ice water that melts, then raises its temperature. So this is a temperature change of the ice water. Now you can't tell the difference between the ice water and the calorimeter water. They're both water. But there is, because we went to the highest temperature, the ice is melting, and we don't know exactly when the ice finishes melting. Otherwise, I could just use that part. But we're letting the ice melt, and then we're letting that ice water also get up to temperature, to the same temperature as the water in the calorimeter. Okay? Now, if we're solving for this H, I'm going to move this MC delta T to the other side. So my formula now will be NH is equal to MC delta T minus MC delta T. And this MC delta T here is this one that I moved over. So this is of the ice water, and this is just the calorimeter water. Okay? All right, so N is the number of moles of ice that I have, and you've calculated that right there. That looks beautiful. It looks like 1.16. So that's number 1.16 moles times the molar heat of fusion of ice, which we don't know yet. Okay, the mass of the calorimeter water. Mass of the calorimeter water, I think was, where do you have it in that first question? Oh, no, not there. It should have been somewhere. To get this number, that's what you had to do. I think it was 200 grams. There was 200 milliliters that you started with, so I think it's 200 grams. So 200 grams times specific heat capacity of water, joules per gram degrees Celsius, times the change in temperature. So the change in temperature of the calorimeter water. So the calorimeter water started at what temperature? I don't see it here. I should have a temperature that it started at. Is this what it started at?
Tanner.
I'm not sure there. Anyway, it's a change in temperature, so whatever the calorimeter water started at, I thought it was supposed to start at 30 or something like that. And then subtract whatever it ends at, which was 23. Maybe that number 10 or 11, where's that number? Right in there somewhere? Maybe that was the number that should be there. So that's the change in temperature of the calorimeter water minus the mass of the ice water. Well, the ice measured 20.9 right there. So that would be 20.9 times specific heat capacity of ice water. Well, it's just water, 4.19 joules per gram degrees Celsius, times the temperature of the, or the change in temperature of the ice water. So it would have started at 0, and then it got up to, did it get up to 23? Change in temperature. Oh, here's the change in temperature of the calorimeter water. That was 10. So this number here is going to be 10 degrees Celsius. Oh, and this is what the ice water ended up at. So if it started at 0 and went up to 23, then the change in temperature is 23 degrees. 23 degrees Celsius. Okay, so I need to multiply those together. Multiply those together and subtract them. Let me just do that. Okay, 200 times 4.19 times 10 minus 20.9 times 4.19 times 23 equals, so that comes out to 6,365.867 is equal to 1.16 moles times H. Notice I'm just bringing everything straight, trying to bring everything straight down. That's good math kind of stuff, and it helps with formulas. Okay, now I have to divide, so I'm looking for H, so it'll be 6365.867 divided by 1.16. Divide 1.16 equals, so this one comes out to 5,487.8 joules per mole. But my answer is supposed to be 6.03 kilojoules per mole. Oh, but this one is in joules, so I can change that to 5 point, and I need to go to 3 sig figs probably, so 5.49 kilojoules per mole. And so when you compare that one with what it's supposed to be, the numbers are off a little bit, but fairly close. Okay, so that's for trial 2. Now do the same thing for trial 3.